This is our Algebra 1 Structure and Method video on Chapter 5, Section 12, Solving Equations by Factoring. Today we're going to use factoring to solve polynomial equations. Now this is a culmination of all of your factoring methods, so as I'm moving through the examples, I'm probably not going to spend a lot of time on the actual factoring methods. So if you need to review that before we start, take the time to do so. It'll make this lesson a lot easier. Finally, we have some wonderful polynomial vocabulary for you. Don't forget that math words are important, so make sure you note these definitions as we move through the lesson. Take a moment and complete the warm-up. If you're not ready to see the answers, pause and restart when you are. Showing answers in 3, 2, 1. How did you guys do? Okay. So let's complete these 4 exercises together. Fill in the blanks and restart the video when you're ready. Okay, so 3 times 0 is 0, 0 times 7 is 0, 0 times 0 is 0, and 2/3 times 0 is 0. This all feels intuitive to you, but this is a formal property called the multiplicative property of 0. Formally, we say that if A equals 0 or B equals 0, then A times B equals 0. This is called an if-then statement. If we switch the if and the then parts of the statement, we get the converse of the statement. Now, this is not always the case, but in this case, the converse is true, and it is the very useful zero product property. Really, all this means is that if your product is 0, then one of your factors has to be 0. You are going to use this property a lot throughout your math career, so let's get to know it a little bit better. Okay, so we need to solve x plus 2 times x minus 5 equals 0. This equation already has 0 on one side, and it's completely factored. So most of the hard work is already done for us. According to the zero product property, ZPP, one of the factors on the left-hand side must equal 0. So let's set each of those equal to 0. Very good. And now we're going to solve each to get x equals -2 and x equals 5. So we have our solution set and we can box our answer. Now, by the way, those curly braces mean that the solution is -2 and -5, none of the values in between, none of the values that are less, and none of the values that are more. For this one, we need to solve 5n times n minus 3 times n minus 4. Now we have a good start again because all of the terms are on the correct side and we're fully factored. How many factors do I have? That's right, I have 3, so I'm going to set each equal to 0. 5n, n minus 3, and n minus 4. I solve each of them and I get n equals 0, 3, and 4. I'm going to state my solution set, 0, 3, and 4 in my curly brackets, and I'm all good. So when both sides of an equation are polynomials, we call this a polynomial equation. Surprise, surprise. They're usually named by the term of the highest degree. So for example, when a is not equal to 0, and that's an important part, ax plus b is linear because it has a first degree. Ax squared plus bx plus c is quadratic, and we've been looking at a lot of those lately, so they should feel familiar. That has 2 degrees. And ax cubed plus bx squared plus cx plus d equals 0 is a cubic function because it has 3 degrees. We need to solve the quadratic equation, remember, second degree polynomial, 2x squared plus 5x equals 12. Now first we need to move all of our terms so 0 is by itself. So I'm going to subtract 12 from both sides. Okay, to get 2x squared plus 5x minus 12. Always make sure to do this because in order to use the zero product property, one side has to be 0, hence the name. Next, let's factor to get 2x minus 3 times x plus 4 equals 0. Remember, we set each factor equal to 0, so 2x minus 3 is 0, x plus 4 is 0. Solving each gives me x equals 3 halves and x equals -4. So I'll throw my solution set, box my answer, and on we go. Solve 18y cubed plus 8y plus 24y squared equals 0. Okay, so 0 is already by itself, But we have some factoring to do. Fully factoring, I get 2y times 3y plus 2 squared. I'll set each equal to 0 and solve. I get y equals 0 and y equals negative 2/3. Okay, now just as an FYI, that last 0, 3y, y equals negative 2/3, it happens twice, and it's called a double root. You may see more multiple roots as the degree of your polynomial gets larger and larger. So, if you're in class, turn to a classmate. If you're at home, talk to yourself. If you're working with a parent, tell your parent. How would you describe the zero product property? I'll see you in the next one.